0.
Okay, hey everyone. If you're watching at home, you probably haven't seen us in a while, but it's time for us to do some more learning labs. And in this situation, we're going to be talking about asynchronous code and how we can use it in JavaScript. There's a lot going on with how async works and how async works in JavaScript. So this is really just kind of a primer that goes over the high-level details of how it might work and how you may use it in your app. But unfortunately, we just don't really have the time to really delve deep into the concepts. So I'm going to try my best to give you a working knowledge of asynchronicity, and specifically, we're going to focus on promises in JavaScript. And hopefully, this will help you in your learning labs or just in general in your web development career. Okay, so let's get started. I'm going to mostly structure this off of kind of the order in the notes, but to some extent, it's going to be a little bit different because I'm going to skip over some of like the exploratory content. Just for reference though, if you're watching this video at home, and that's going to be all of you because it's just me and Leah in this video, make sure that you are up to date on your JavaScript basics and specifically your function basics. What arrow functions are, how you can pass functions as arguments to other functions, and stuff like that. We're going to pass functions to other functions all the time in this video. So if you don't remember how to do that, please make sure that you head back to either our previous video or other online resources to make sure that you know how that works, because we're going to be doing it all the time. But yeah, so with that in mind, let's talk about asynchronous programming. I'm going to first tell you what asynchronous programming actually is just in general. So one of the things that we at TeacherLay also do when we teach kids computer science, and you probably learned when you started computer science, was that, hey, you know, all your code runs one line after another. So first, you know, we do this thing. After that's done, then we run the next line of code. Then we run the next line of code, et cetera, et cetera. This is often taught as like sequential programming. And in our case, we're going to call this synchronous programming. So synchronous means one thing is happening after another. And that's fine. There's nothing wrong necessarily with synchronous programming, but it's actually kind of slow, right? So let's say, for example, you're on Facebook, right? And when we open up the Facebook homepage or the Twitter homepage, right, you need to get a lot of information. You need to get all the list of your friends. And then once you get the list of those friends, you need to get all of their profile photos, and if they're online, and all the posts that you want, and all that kind of stuff. And so if we did it synchronously, right, without looking at any code, just very high level, it would look something like this, right? First, get all your list of friends. While we're getting a list of friends in our sequential model, we can't do anything else, right? So we're kind of just doing nothing. And the user can't interact with our page. Then, after that, then we have to get all the list of our friends' images, and then we get all of the posts and all that kind of stuff. And if we only use synchronous programming, it would take a very long time for our page to load, which is bad. Because as web developers, we want our experiences to be snappy and interactive and, you know, usable. And this problem actually arises itself in almost all of modern computing, right? Think about like my desktop right here, right? If I want to listen to music, right? So I'm playing music on my headphones. I want to be able to do other things while I'm listening to music. I shouldn't have to wait for the song to finish, then I can switch to my web browser, and then I can't listen to music until I'm done using my web browser and all that kind of stuff. And similarly, imagine if you're like a server and you're receiving a bunch of different requests, right? You don't want to only have to finish the next request after the first one is done. What if you're getting millions or trillions of requests? You know, that's just not going to work. So this is where we're going to introduce asynchronicity or asynchronous code. What this is a fancy word of saying is basically you're not guaranteed that your code is going to go one after another. Maybe we run some code. This line's not done yet. We'll start something else, right? And then maybe we'll wait for this line to finish somewhere else in our code and we'll do something else. Or there's just some shenanigans at play. Asynchronous is a very broad term, and it actually has a lot of different meanings in programming, but this is the main fundamental idea that we're going to focus on. If that didn't make sense, I've included some links in the notes where you can learn more about asynchronous programming. I would definitely check those out. The entry by Elegant JavaScript, which is like this block quote and this thing right here, is super, super useful. And I'll quickly just go to the diagram and quickly explain what I mean here, right? Synchronous, so this event happens, then this event happens, blah, blah, blah. Asynchronous means we can start two things and they'll kind of like run at the same time and they might finish at different times. So overall, that's the concept we're going to examine today. As I said earlier, I don't assume you have any experience with asynchronous code. So if you do have experience, you're going to know about things like multi-threading and green threads and kernel level privileges and stuff like that. Let's ignore all of that today. JavaScript doesn't support multi-threading out of the box. It's single-threaded, and it uses this thing called an event loop. And we're not going to really talk about the event loop, so I've included some links, maybe at the very end. But if you don't know what those words mean, don't worry about it. Multi-threading and concurrent or multi-processing and asynchronous code in JavaScript, in my opinion, is actually pretty simple and easy to understand compared to it in other languages when you have to dip into OS threads. And hopefully you'll agree with me that it's kind of simple. But anyways, I'm blabbing a lot. Let's actually talk about some stuff. So I'm going to introduce just like new vocabulary and stuff that I've outlined in this table of contents in the notes here. So just, if you don't remember what a word is, check the table of contents or give it a Google. So there's this thing called an API. An API, or application programming interface, is really just a way you can interact with like a system, right? So this is like how all of the internet works, right? If I go to github.com and I type in this address, this page is not on my computer. It's somewhere else in the internet. And so we need to find that place on the internet and then get all the information we need. And the way we do that is through an API. And specifically, we do that with a HTTP request. You don't really need to know what that means. Long story short, is an HTTP request is a way that we get stuff from like websites and web pages and servers and stuff on the internet. And it's a very standard set of things. So it's a good skill to know how to use, because if you do any sort of web development, you'll use HTTP requests like all the time. Okay? So if that makes sense so far, we're going to continue and actually talk about one possible HTTP request. So as I said, there's many different APIs. One API that I think is pretty cool is called the Pokemon API. So the Pokemon API has just a bunch of information about Pokemon. And I really like Pokemon as a kid and also now. And so here you can you can't really see it in the address bar, but it's also in the notes. But you can type in the name of a Pokemon, and then it's going to give you information about the Pokemon. So I'm going to zoom in here. Oh, this is kind of hard to see. We'll go to the Poke API website. And this is like maintained by the community. So this doesn't really have to do anything with like the actual Nintendo company. So if I go to here, right, this is some documentation, and it says, hey, if you do, get and then something, you type in some URL, you can get some information back. And this looks like a JSON or a JavaScript object. We've covered this before. If you're not familiar, I encourage you to go back and review that note. But yeah, it gives us information, right, about the Pokemon. And you can imagine, obviously, there are examples past Pokemon. So what we want to do is get this information and then do something with it. Does that make sense so far? We're chilling? That's a rhetorical question because I'm the only person in this
Makes
call.
sense to me, Matt.
Oh, thank you, Leah. Okay,
Of course.
so yeah, I want to use the Pokemon API. So the way we would do that is with this thing called a fetch request. So I'm going to pull up the code on the side here, and this is the only time we're not going to be doing live coding. Everything else I'm going to do live. So if you check this thing, this code right here, this first steps with fetch, this is what the code looks like. And purposefully, I have not introduced what fetch is. Yeah, because I want us to use some critical thinking skills and hopefully stuff that you've learned over the course of this Learning Labs crash course. So this is how you would get data from the TeachLA budget or the Pokemon API website. So as you can see, fetch here is a function, right? Because we have the name, then we have the parens. And it looks like it takes in one parameter, or maybe more, but at least one. And this looks like a URL, right? So this is one way we can get information. And this would be the same thing as if we visited this URL in our browser and then just like viewed the result, okay? Then, now we have this code here. This is where things get a little tricky, right? So we have this thing, it's like dot, then, and then, ooh, something is here. This kind of looks like a function, right? If you remember from our lesson on functions, this is an arrow function. So this thing that I'm highlighting right here, this is an arrow function. So it's a function with no name. And it takes in one parameter. The parameter is called response, or the argument is called response. And then we do something, argument.json. I'll explain what that means in a moment. This entire thing is being passed to the .then function. So the critical thing here that people often struggle with is what we pass here is a function. It's not the response of the function, it's the function itself. Okay? And if you remember from our JavaScript tutorial, this dot then usually has to do with something kind of like object inheritance or a function belonging to another function or a property of an object. And if you remember, everything's an object in JavaScript. So this dot then is actually attached to this fetch function. Then we have another dot then. Wow, things are getting really spicy. And yeah, here again, we're passing another arrow function in. And this one, again, takes in one argument. The name we give the argument doesn't matter. We get to pick the name. We're just going to call it data here. And we're going to do some stuff with the data. Okay?
Hey, Matt.
Yeah, what's up?
I noticed that you call then twice. Could you tell me why I can't just go ahead and call response.json and pass it straight through there?
Well, you can't call .json here because this is an argument to a function. So that's just the name of the thing. We can't do stuff to it. In order for us to do stuff to it, we have to chain it with then. And we'll actually cover exactly what this means in a moment. Leo, did that answer your question?
Yes, Matt, it did. Thank you. I just wanted to make sure that we were going to talk about that.
Okay, yeah, solid. Okay, great. As you can see,
so
you know, this is A1 content right here. But yeah, the thing I want to emphasize here is that by looking at the code, we were actually able to guess a lot of correct things about how fetch works. And I think this is a really important skill for you moving forward because we're almost at the end of this crash course, and I want to make sure that everyone watching grows as a developer. So looking at the code and looking at what we know about JavaScript, we already know some things, right? Fetch is a function. Fetch returns something, and whatever fetch returns has a dot then property, which is itself a function. And dot then takes in an argument, and that argument is also a function. So a lot of functions going on. So again, that's why I said it's really important for you to make sure that you know how your functions work, because it's going to be very relevant. But yeah, anyways, besides the point, that's a quick guess at how this works. But you know, that wasn't very super illustrative, and we didn't actually run the code. So let's actually do that. So I'm going to open up my, oh, that's not what I meant to do. Oh no. I'm going to open up my terminal here. And I'm just going to zoom in on this so you can see what's going on. And so I'm going to go into the node console. This is just like a way to write JavaScript. I wouldn't really worry about this if this doesn't make sense to you. So we're going to use fetch. So I'm going to use this Pokemon API just because I think it's cool. So Ditto is like my favorite Pokemon. So I'm going to take this and let's try a few things. So I'm going to first type in fetch and then just this thing. Oh, is fetch not in the node?
Fetch? Yeah, I don't think, does Node have fetch? Wait.
No, Node has fetch. It needs to be polyfill.
I think it's a browser implementation.
No, it's because it doesn't have. Okay.
Yeah, okay, it's the browser. Let's
take a step back. Obviously, I already knew that and was just testing all of us. Instead, I'm going to jump into my Chrome DevTools, and we're just going to code in the console like professional developers. Can I pop this out? That's what I want to do. Am I dumb? Great. Okay. So let's just take a look at this console right here. Hopefully you can see what's going on. So in this console, we're going to write a bunch of code. So yeah, let's do what I was going to say I was going to do earlier. So we're going to do fetch, this thing. So if you remember, this is just going to return, when I hit enter, it's going to return whatever this function returns. So this thing returns a thing called a promise. And I'm doing this kind of out of order of the notes, but it'll make sense. So a promise sounds like the code is promising you something. And that's exactly what a promise is. A promise is a special type of object in JavaScript. And a promise basically says, hey, we're going to run some code that's asynchronous. So if you remember from earlier, asynchronous means that the code doesn't necessarily run one after another. And the promise says, we'll let the asynchronous code run. And eventually, one of two things will happen. It's going to succeed or it's going to fail. And if it succeeds, we'll do one thing. And if it fails, we'll do another thing. So if you think about this in the grand scheme of things, right, this is a very useful paradigm to have, right? we make a request to an API, it's going to take time. It has to go through the internet and through the wires and all that kind of stuff. And while it's doing that, we're kind of just chilling. We can't really do anything with that data yet. But as soon as the request finishes, so we get all the stuff, then we can do something. That's what a promise is. Okay? So fetch returns a promise. And as we kind of guessed earlier, promises have this function called .then. So .then is a function, and it takes in one argument. That argument itself is a function. And this is called a callback function sometimes. So I'm going to refer to this as a callback function from now on. Okay? So the callback to then is going to get called after the request succeeds. Okay? That's it. That's it. So I actually technically do not have to care at all what we get back from this. So we're going to do the most basic example, right? So I'm going to do fetch. Fetch returns a promise. Then I'm taking .then, right? Because we're using something on the parameter that it's done. And .then is going to take in a function. So I'm going to just put in an arrow function that doesn't care about what we get. And I'm going to just console log that says we finished our request. Great. And just make sure I don't have any syntax errors. Yeah. So I'll hit that. It looks like it finished pretty instantly because the request probably happened very quickly. So that makes sense. But yeah, that was our very first promise. Now you might say, Matt, that seemed pretty useless because we didn't do anything with the data that we got. And you would be right. So that's where the argument that the callback function takes comes into handy. So this blank parameter we had right here. So I'm going to do that again. Except this time, I'm going to say, okay, I want my callback function to actually take in the data that we get as a response. And it turns out, fun fact, that we will at least always get one argument back. And this argument is going to be the data that holds everything we get from the response. So we can call it whatever we want. I'm just going to call it E for the sake of brevity. And then here, I'm going to just do console.log E. Okay, so this is pretty simple. So we make a request, then as soon as the request is finished, we're just going to do some stuff with it. So I'll hit enter, and then the promise ran, and then after the promise ran, we got like an object. It's very complicated, right? But so far, this looks kind of reasonable. And if we explore the object just for a little bit, right, we'll see that there's some stuff here, right? Some useful stuff, right? The URL, maybe the status, you know, if it was okay, all that kind of stuff. But still, this seems not that useful. I don't think this is you know, something that I would really want to use. We want to actually get the data from the website. So now we can do that. I'm going to do this again. And this time, I'm going to introduce one more new concept, right? So far, we knew that fetch returns a promise. For all promises, there's a .then thing. And once the promise is like resolved or succeeded, it'll call the .then function. So a cool thing is that .then itself returns a promise. So fetch returns a promise, and .then always returns a promise. So what that means is we can chain .thens. We can add a .then on the end of every other .then that we write. And so that's exactly what we're going to do here. So here, I'm going to use the JSON function. There's no way you would have known this, but for fetch, the thing that gets returned, if it's successful, you can call .json, and it'll like convert the thing into an object that we can then traverse. Okay, so I'm going to do that. Then, and see how that wording is done. Once that's done, then I'm going to do something else. So I'm going to do .then again, and this is I'm going to call this thing data, and I'm just going to console log data. And you might say, wow, Matt, that did not seem very useful, right? Isn't that the same thing that we did last time? But we're going to find out in a moment that it's not. So, wow, this is a very different answer we got from the previous one. Now we have some keys that look like they mean something. So if you played Pokemon, this will make sense. If you haven't, I'm sorry. But it has fields about the Pokemon, right? What moves it has, you know, what names it has, the sprites, which is like the animation and the drawing of the Pokemon and stuff like that. Okay, so that was our very first case of using promises. And if this was very rushed and like, you're like, man, that was really fast, it's totally okay. I'm going to go over a few more examples and how we can use this with React. But I want to really highlight two important things that we've just learned. So the first is that a promise is a special type of object in JavaScript that represents an asynchronous action, right? One that when you call it, it might take some time and stuff is going to happen, blah, blah, blah. Eventually it'll finish or fail. And so far we've learned that all promises have like a member function called then. And if the promise succeeds, it'll call whatever you pass to then, giving it some data. And that's what we've done here. And we can chain .thens precisely because .then itself returns a promise. Okay, that was a lot of words. I said the word function like 100 times. I'm gonna say the word function like 100 times more. So you better be comfortable with functions. But hopefully that should give you a very first like brief outing of how this works. And again, I'll go over how this works with React in a moment. Okay, so the next natural question that you might have is, great, what happens if it fails, right? And this happens all the time. Maybe, for example, I introduce a typo. So I'm going to copy paste the exact same line of code, but here I'm just going to add a pokey API as a random line. So it's going to fail, right? Because nothing exists at that website. Okay, so that's not great, but this is not very helpful, right? If your user is not even using their console, they're not going to see this. But you may want to display an error message, for example, that says, hey, something has failed. You should check that out. So we're going to learn about this new thing called .catch. So if you've ever programmed in languages like C or C++ or Java or Python or almost every modern language, there's something called a try-catch. And so a try-catch is not very important, but basically you try something, and if it fails, you do something else. That's the concept. And that's what the catch means in this concept. So we're going to try the promise, but if the promise fails, we're going to do something else. So .catch is another thing that every promise has. And specifically, that means I can add a .catch anywhere I want in this chain. I can add it after the fetch, I can add it after the first then, and after the second then. Okay? But where I put it matters, because let's say this fetch succeeds, but then the JSON fails. If I want to catch that, I need to add the catch after wherever the failure point might be. So I'm going to be safe and just put the catch at the very end. And catch works exactly like .then. You pass it one function as an argument, and this time the argument is going to be the error that we get. So I'm going to call this error, just so that's very clear. And then we'll do console.log error. So I'll call this again. And this time, right, now we actually got a new thing logged to the console, which was what the error was. And it says type error failed to fetch. And so basically it's because this thing failed. And there's more information you can get about the error. You can look up the HTTP error API on Mozilla. For now, we're not going to do that because it's not a great use of our time. But hopefully, you've now learned that this is how catch works. So catch and then are two different member functions to any promise, and they respectively work if the promise succeeds and if the promise fails. So this covers like 95% of the beginner use cases of promises. And very rarely are you going to write your own underlying code that, does things like really make an HTTP request or call some browser or OS API. Usually there's some very high level thing like fetch, and you just need to tack on a .then and do something with what you're passing. So the big thing I want to point out though here is, again, this is very tricky because there's a lot of functions around, but promises are an object. They represent an asynchronous thing, and they have two method functions, then and catch. And to each of those, you pass a callback function. And that callback function gets called once the thing succeeds or fails. And I know I've said that a lot, but I really want to make that clear. Before I continue on to some examples, Leo, have I confused you at all yet?
No, Matt, I think that this has all been quite clear so far. Thank you.
It sounds like insanely sarcastic.
I'm not trying to be sarcastic. I was actually trying to be serious.
Okay.
I'm sorry.
No, you're good. Don't worry about it. Okay. Let's see. What else do I want to talk about? Very quickly, I want to talk about non-blocking versus blocking code. So the thing that's kind of strange about .then compared to synchronous code is that after you do your dot then, like other stuff happens. So I'm gonna add this example. So if you take a look in the bottom right of the screen, we're making our fetch. This semicolon, right, means like we're gonna do the next thing. And we're gonna say log high. So I'm gonna hit enter. And, oh, sorry, I typed it. So I'm gonna hit enter, and let's take a look at the order, okay, of these things. So first, it logged high, then it actually logged the information about a Pokemon. And this might be kind of strange for you, because you might not have expected that. You might have been like, hey, should we call the fetch first? Shouldn't the fetch have finished first? This is a key part of asynchronous programming, right? Is that when you write your code line by line, it might not execute line by line. And in this case, we went over to console.log after we started the fetch. The fetch didn't finish. So this happens almost all the time whenever you use fetch. And this is something important to think about, right? You cannot, for example, run a line of code after a fetch that requires something that we're fetching. That's bad. You should do that with a dot then chain. That's logically how you should do it. You should not put line after line. If you do, you're gonna have bugs in your code, and it's not gonna work properly, and you're gonna be sad. Now you might say, Matt, but I really want to do that. I really need, to do it, and I can't do it with the dot then for whatever reason. Okay, that's okay. JavaScript has a way that you can do that, and the way you do this is called, with two keywords called async and await. We're not going to really go into them in too much depth, but I'm going to show you it very quickly on this code example right here. And I'm also going to talk very briefly about some internal promise stuff. Okay, so this function is called resolve after 1 second. What does it sound like it does, Leo?
Excuse me, Matt?
This function is called resolve after 1 second. What do you think it does?
No, Matt, I'm going to take a guess here. I think it sounds like it's going to resolve this promise after a second.
Exactly. So in this case, as you can see here, we're using the new promise keyword. So that's like, we're making something, like object-oriented programming. And in this case, long story short, details are not important. It's in the notes. You can read the notes if you want. But they say, after a second, it's 1,000 milliseconds, we're going to say the promise succeeded. Okay? That's it. That's what all that matters. So now we go to here. Immediately, just say, hey, there's an async. There's an async. So an async function means that the function is not synchronous. That's really all it means. That means that we can use the await keyword. Okay, so what the hell is the await keyword? So the await keyword, unlike promises, is what we call blocking asynchronous code. So in this example that we just did earlier with the dot then, we noticed that we started a promise, but then we just kept on doing stuff after, right? Await, on the other hand, suggestively sounds like we're going to wait for something to happen. So what an async function will do is after the await, the thing you put here is a promise, okay? Like this thing, or like the fetch dot then, or whatever. It will wait until the promise is resolved. Until the promise is resolved, it will not run any more code. So if you look at here, right, this console.log depends on the promise. So it would be really bad if we added a dot then here and then just added the console log, because it wouldn't work the way we wanted it to. But since that we're using the await code, what that actually means is that it's going to wait for the promise to finish, then it will fill the value of the fast variable, and so the console log will work as expected. Async await's a little bit more complicated than just what I explained right here. There's actually quite a few intricacies with this, and also promises that we didn't really talk about. But I want to give you just enough of an idea so that when you look up code online, or you go on Stack Overflow, or you read documentation, you now at least know what is going on. So just give me 1 second. Okay, sorry about that. So, great. Let's walk through then maybe an example, and then we'll call it a day, or an example or two, because it's been pretty long, and I'm sure it's a Friday night. Leo wants to do other things with his life. Okay, so I spun up a very basic create React app over here on the side. So we're going to do two things. I'm going to first actually add a user input. So this is quick hooks review. So if you don't remember, hooks are something that we covered, I think, in lesson 13. And basically, they're another way that you can model state. And I'm going to do it just because it's going to be faster for me to type. So basically what we're doing here is we're saying, hey, we're going to have a variable called current Pokemon, and it's going to store a string that the current Pokemon we're going to be looking up is. And then the set current Pokemon function is how we change the state. So that's what the this.setState would be if we were using class-based components. Then I'm going to add our normal onChange handler. So if you are familiar with React, we've done this so many times. And this is like, very simple code. We're just going to take an input and we're going to do some stuff with it. So now I'm just going to add this input right here. And if I'm going too fast, we've covered this before in our intro to React, in our intermediate React lessons. I would definitely recommend that you take a look at those. But I'm just going to breeze through these because this is not the focus of our lesson today. Great. So let's just double check that this works. So I've added an input, and yeah, there we go. Great. So the premise of this is I just want to be able to search for Pokemon. So we're going to also make one more function that's an onSearch. And this one doesn't need any parameters. And this is the function that's going to do our fetch. OK? So first thing I want to point out, we didn't add async here. And this is a very common mistake that people make. I'm going to tell you right now, we're not going to use async await. And we're not going to use await in particular, because we don't want to have blocking code. Given what I've told you, Leo, can you think critically about why we wouldn't want blocking code in a website?
Well, especially in a React app, right? I mean, think about what's going to happen when all of a sudden we're just trying to render again and we have a blocking function call.
What is going to happen, Leo? I don't know that much about React. Can you?
Oh, you don't know that much about React? Oh, excuse me. Well, what's probably going to end up happening is it's going to create some very unpredictable behavior in our web app. It's going to have certain updates happen way later than they were supposed to, and things are going to get thrown completely out of whack on the web page for us. And we, the end user, will have no idea why.
Exactly. As Leo pointed out, right, React is a lot of stuff under the hood, but also keep in mind, if it was blocking, and we use await, the user cannot interact with the web page at all while the search is happening. That's not very good behavior, right? That would suck if you just couldn't use any website for 20 seconds while I had to pick up something. So we want to make this non-blocking. That means we're not going to use async await. We're going to use promises and the .then chain. Okay, so far, so good. Okay, now I have my fetch. If you're not sure what this means, this is like a string comprehension literal, but basically it just means like, hey, this string is this, plus this thing is a variable. The variable is whatever we've added here. Okay, so this fetch is a promise. What am I going to do after I get something from a promise? I'm going to use .then. So I'm going to put .then. What goes into .then? A function that takes in one argument, which is like whatever we get back from the fetch request. So I'm going to just, I don't know, call this response. This is like the convention. If you don't remember, I'm just going to very quickly point this out. If you do the arrow without the brace, implicitly it returns this. So the promise returns that. This is something you should know. So we're going to first convert the thing to a JSON. You will almost always do that every time you use fetch. Then I want to do something else. So now that I have my data, I want to render it to the page. Well, as we learned from our intermediate React design principles, anytime something in our app is going to change, we have to use state. So we may have not thought about it earlier, but we actually need to use state again as well. And we're going to just call this like Pokemon information, set current Pokemon, or set information. So this is just, again, another state hook. And if you don't remember what this is, please check out the information in our React hooks lesson, lesson 13. So now I'm just going to say, okay, so now once we get the data, let's first just log the data, and later we'll figure out exactly what to put in the information. Okay, last thing is I need to add an on click to this button so we actually call this thing. And there are a few issues with what we've done, so I'll quickly just go through them one by one later. But for now, let's just see it in action. So I have my code over. Oh, can you pop back in? Great. Okay. So I'm going to type in Ditto. Ditto is a Pokemon. Hit search. Oh, we got some stuff right here. Okay. I don't know. Let's just take the ID for now. I think that's pretty reasonable. So I'm gonna add a p tag here. Your Pokemon's ID is, and then the brace means we're executing JavaScript, and here I'm gonna put in Pokemon information. And here I'm gonna say, hey, we're gonna set Pokemon information to data.id. Great. So let's do that again. Ditto, search, bam. Lit. Okay, so we're doing good. That was pretty quick, but I want to point out one thing. We didn't do anything different in this React app than what we did when we were just demoing it through the browser. And the nice thing about React is that promises and async work the exact same way that they would work without React. And this is because React is purely a client-side library. So it's very convenient. And in general, when you do stuff like this, you don't really have to worry about how things work with React. With one exception, which is state management. So another reason I used hooks is because I want to avoid this .setState. And the reason why is because this .setState is actually asynchronous. And we maybe I briefly mentioned this before, but I don't know if we have. But yeah, when you call this .setState, you're actually not guaranteed that the next line after this .setState will have the new state. It might take a little bit of time, right? And that's because React has to do some virtual DOM diffing magic. And it's the same thing here. Hooks are also technically asynchronous, but both of them are written in a way that they kind of seem synchronous out of the bat. But again, as an end user and an end developer and someone who's making learning labs, this is not a huge deal, but this is an area of bugs. And I would definitely encourage you to ask me or Leo if you have any questions about this thing, or just in general, if you run into a problem, give it a quick Google. It's very common. Okay, so this works pretty well. But I have a question for you now. So let's say I search a Pokemon that doesn't exist, right? Like Leo. Without the console log, I have no idea what's happening. Is my search still going on? Is my internet really slow? Or is my search query actually wrong? Leo, is there a tool we could use here to, I don't know what the word is, maybe grab or take the error that we're gonna get?
Yeah, I think we're forgetting a certain thing called, I think it was catching the error.
Great. Yeah, I like that idea. So we're going to add a catch. And if you remember, a catch just is we just use the dot, we attach it to a promise, and the catch is going to have some error. So I'm going to add another paragraph tag here. And this paragraph tag is going to just be like an error thing. So I'm going to add another hook called error message, set error message, use state. This thing is going to be error message. And so in our catch statement, right, this catch is going to only run if it fails. And we're going to put in a function. So the function, again, is going to have one thing. It's going to be the error. And then I'm going to do two things. I'm going to first log it to the console with console.error. It's very convenient. Just helps us out a bit. And then I'm also going to change the error message on the screen so we see that there's something wrong. So I'm going to set it to error, I think, for now. So now, if we search this, I'll type in Leo here. Oh, it says error is not a string. Sorry, give me one sec. Let's do that first. So we're going to do this. Search Leo, set up our console. So we've gone some stuff. Very spooky. It says that there's a problem. I believe we can probably just do string error, and this should work. Let's see. Yeah, there we go. So as you can see, ta-da, something's worked out. We're chilling. And so in this case, it's saying unexpected end in token. You would have to dig in a bit, but this just basically means the API was not, it didn't respond properly, right? So it means there was something wrong. And if you wanted to, we can instead change this at all to say there was something wrong with searching your Pokemon. And we'll do that. We'll hit search. And then if you notice, there's a bit of a lag, right? And that lag is because it actually performs the fetch, as you heard my voice crack. And then once the fetch fails, then it reports that there's a problem. This is very basic, right? Like in an actual complicated web app, you would probably add a lot more functionality, maybe a loading spinner and, you know, like a red error message. We don't have time for that. But what we do have time for is to just very briefly, again, go over this example. And so if you notice, this isn't actually that much code, right? This was like, what? This is the only promise, but weird stuff we had to do. This was like 11 lines of code. So asynchronous code sounds very scary. Eggert will definitely make it sound very scary to you when you take 111. But it's not. It just requires a very core understanding of how promises work in JavaScript, how .then and .catch work, and how passing functions to other functions works out. Yeah. And then obviously there's way more stuff we can do with this data. You know, like for example, it gives you a list of all the Pokemon's abilities. So you can make an entire Pokédex out of this API using hooks and the fetch API and all this kind of stuff. But again, I just want to give you guys enough of a proof of concept to understand what's going on. Okay. Yeah. So before we end this video, that's probably gone pretty long already. Let's quickly talk about how this would be useful for your learning lab. So there are a few ways this could be useful for your learning lab. So one is with the web API, which is like the HTTP stuff. So, you know, if you need to like use Google Images or like somehow other include some sort of search functionality, or you're getting some information, this will be super, super relevant, right? So maybe, for example, you know, you want the user to like input something and then you'll check if that it's like a, I don't know, Pokemon. That's a terrible example. You can, wow, I really should have come with some canned examples. There's a lot of APIs. So for example, Spotify is a really popular one. Let's say you're making a learning lab based around ML and logical classification, and you want to be able to search if a song exists and then get information about the song and then run it against your classifier, right? So ignoring the ML portion, in order to get the song, we have to call an API, right? We have to say, hey, Spotify, do you have a song called All-Star by Smash Mouth? And if you do, can you tell me what genre the song is and when it came out? Maybe those are the parameters that go into your model. If you imagine, right, how I worded that makes it sound like we would need a promise, right? We fetch the Spotify API. Then once it's done, we get the information. Then once we process the information, we pass it to our model. And here's something else to point out. Your model is probably also asynchronous, right? It probably needs to do some stuff in the background before it can calculate, you know, what other songs it think you might like, right? And so oftentimes these things are also asynchronous. If you use TensorFlow.js, for example, they also use async await and promises inside their code. So that is one super common example of how async await and fetch would function in your learning lab. Another is with file uploading. So when you upload a file, so let's say your learning lab, I don't know, involves convolutional neural networks, right? And maybe it's called, I don't know, what is it called? No filter, right? So you want the user to upload an image and then it'll run a CNN over the image. So when you upload an image, that is an asynchronous operation because you don't know how long uploading the image might take. Maybe their internet connection is bad or something, right? So how you would structure in your code verbally is you'd say, hey, once you start uploading the file, I don't know, show loading bar. Then, once the file is done uploading, process it. Then, once the file is done processing, run it through our CNN. And then if at any point it fails, we should catch that error and display it to the user. And we didn't really go over this, but you can go very granular with your catch statements and say, oh, there's an error at this point of the stage. Maybe when you uploaded the file, there was a corrupted chunk, or your file is not the right file type, or it failed in the model. Those are all different steps, and you can reflect that back to the user. That's another common use case of async await and promises. Okay. Yeah, I think that covers most of the stuff that we were going to talk about today in terms of async await. I didn't go one for one with everything that was in the notes. The notes spend less time talking about the practicalities, like we didn't build this thing in the notes, but it spends a bit more time talking about the principles behind async await. So if you want to read the notes, please do. I spent some time on them. And again, if you have any questions, feel free to ask us. I'll just also note that we brushed over some very high-level concepts. So I included appendix entries on callbacks and how concurrency actually works in JavaScript. And I'm a big fan of the Mozilla Developer Network. I've included a bunch of links where you can learn more and really figure out what we talked about and how it applies to your learning labs. Okay, Before I call this, Leo, any other questions? You think I've missed anything or any things that I could clarify?
No, I think you did I think you covered all the big points there, actually. Yeah. Overall, just to reiterate, yeah, if you guys have any questions on this stuff, some of the other possibilities you can do with promises, like maybe how we're going to deal with returning promises, if we're running a web server, that kind of thing in the backend lesson. Yeah, just feel free to come to our office hours. We'll all be hanging out, and we're here to answer questions.
Yeah. Okay. Wow. I'm pretty sure this video is like 40 minutes long.
Somewhere around there.
If you're still watching, like, okay, look, I'm gonna be honest with you. We have like a 10% like sustain rate until the end of the video. So for the one person who's still watching, thank you for sticking with us. I hope that you watch this on 2x speed because it's way too long. And I should have prepared the examples. I should not have stalled there. But yeah, that's it. If you have any feedback for the Learning Labs, please comment below. We respond to all the comments, or email us or Slack us. Please smash that like button. Please smash that subscribe button. And we'll see you next Wednesday as Leo talks to you about backend. Great?
Alrighty.
Great.
See you guys then.
It's going to be a great time. I promise. Because we talked about
yeah. See you, Matt.